everyone, welcome to Algebra 1, Lesson 20. Let's get started. We're talking about algebraic expressions, we're talking about sentences, as well as conditional equations. Now, none of this is difficult, but it is a lot, so we are going to jump right in with the vocabulary term numerical expression. A numerical expression is when we use numbers to express something. It's a meaningful arrangement of numbers and symbols that designate a specific value. So the value is what the numerical expression stands for. The value is that one specific number. So each of these are numerical expressions. 4, 6 plus 3, 4 times 2 plus 3, 7 times 8 plus 4 divided by 5 plus 2. All of those are numerical expressions. These are their values. 4 just has a value of 4. 6 plus 3 just has a value of 9 because that's what 6 plus 3 is. 4 times 2 plus 3 is 20. Letter D is 12. So those are each their values. Now an algebraic expression, that is a numerical expression, and it's also when we have variables included. So when you include variables in your expression, it is an algebraic expression. So all of these are algebraic expressions. 6 is just 6 and its value is just 6. For the rest of my algebraic expressions, the value depends on the variable. Because here my expression is x plus 4. Here x squared minus 6. Here x times x minus 4. So their particular values change, they are dependent on the variable. So if my variable x is equal to 3, these are the following values. You would put 3 in place of x. 3 plus 4 is 7. 3 here, 3 times 3 squared is 9, minus 6 is 3. Here, 3 times 3 minus 4. I think I have something incorrect there. Oops, that should not be a minus, that should be a plus. Something is wrong. Ooh, let's change that. 3 times 3 plus 4. 3 plus 4 is 7, times 3 is 21. And so those are the values. If you changed x, you would change the values. Now I want you to look at your book on page 92, 20.b, where it says statements and sentences. So if we wish to make a statement about certain quantities, whether or not they're equal or not equal, if you would write that out as a sentence in English, it could be something like this. The number of peaches equals the number of apples. That's letter A in section 20.b. B is the number of peaches does not equal the number of apples. Letter C, the number of peaches is greater than the number of apples. Letter D, the number of peaches is less than the number of apples. So that's what it would look like if you wrote it out as a sentence in English. But what about if I wanted to express it mathematically? I could express it using an algebraic equation and these symbols. I have n sub p to equal the number of peaches, n sub a to equal the number of apples. And I know it might be difficult for you to see them, so you can also look on your book and see how they have n sub p and n sub a. When I say sub, I mean that little letter next to the bigger letter. Then you have your 2 lines. We know that stands for equal to. The 2 lines with a cross out through it, that's not equal to. Then the open caret is greater than, closed caret less than. So the sentence A is the number of peaches equals the number of apples. So I could write n sub p equals n sub a. So that would be the number of peaches is equal to the number of apples. B says the number of peaches does not equal the number of apples. So I would write n sub p does not equal n sub a. And that would show the number of peaches does not equal the number of apples. Now I have sentence C. The number of peaches is greater than the number of apples. So I have the number of peaches greater than the number of apples. So I use my greater than symbol. Remember, the open end is always towards the bigger one. And when you read it across like this, it's always this is greater than because it's open towards the bigger one. If I wanted to say that the number of peaches is less than the number of apples, I use this one with the closed end. So the number of peaches is less than the number of apples. So that's how I show those statements by writing the algebraic sentences. You will be practicing, like you did last year, writing out these kinds of algebraic statements, these kinds of algebraic expressions, and then solving them. So it's good to get used to the wording and how that can be shown. So study that part, section 20.b, so that you feel comfortable with how that is phrased. So now we're going to look at our conditional equations. I have 5 equations up here on my board. I almost said 6, I don't know why. I have 5 equations set up here on my board. These are all algebraic expressions. Some of them are true and some of them are false. 4 equals 3 plus 1. 4 plus x equals 2 plus 2 plus x. 4 equals 6. 4 plus x equals 6 plus x. X plus 4 equals 8. Let's look at the true ones. The true ones are A and B. Well, A we know is true because 3 plus 1 equals 4. So that's true. There's no way that can be false. This one, 4 plus x equals 2 plus 2 plus x. Well, I have 4 on the one side. Then I have 2 plus 2, which equals what? 4. So I'm saying 4 plus x is equal to essentially 4 plus x. My numerical value is the same on both sides. So whatever x is, I'm adding it to the same number, so it's always going to be true. Over here I have 4 equals 6. No, that's not true. 4 and 6 aren't the same, so it's false. Here I have 4 plus x equals 6 plus x. Again, it doesn't matter what x is, this will never be true because you have 4 on this side and 6 on this side, and that's it, no other numbers. So if x is 1, on this side you're adding 4 plus 1 is 5. On this side you're adding 6 plus 1, which is 7. If x is negative 3, 4 plus negative 3 is 1. 6 plus negative 3 is 3. So it will never ever be the same because what you're adding to it isn't the same. So it's a false equation. X plus 4 equals 8 is a conditional equation. That means it depends on what number you use for x. So let's say that I say that x equals negative 2. I'll put negative 2 in place of x. Plus 4 equals 8. Negative 2 plus 4 is positive 2. Does 2 equal 8? No. So x is not negative 2. Nope, wrong. Well, let's say x is 4. Let's try that one. Put 4 in place of x. Plus 4 equals 8. So 4 plus 4 is 8 equals 8. Is that one correct? Yes, it is. So 4 is correct. X equals 4 makes it true. So whatever number makes it true, we say is a solution of the equation or a root of the equation. So it's a solution or a root. And we say that that number satisfies the equation. That's important to know that vocabulary because you'll see it in your book. You might hear me use it. So you need to know that. The solution or root is the number that will satisfy or solve the equation and make it true. In your book, you have 2 examples, okay? I want to kind of skip over those so that the lesson doesn't become too long, but I do want you to look at them, especially if you have trouble with your practice, okay? It says, for example 20.1 on page 94, does negative 2 or positive 5 satisfy the equation x squared equals negative x minus 5? So first you try negative 2 and put that in place of x. Be careful with your negative sign. And it works. Then you try positive 5, put that in place of x. It doesn't work. So negative 2 is a solution, positive 5 is not a solution. And number 2 does the same thing. Now you are going to do the same exact thing for your practice. It says is either negative 2 or negative 5 a root of these equations. So pause your video now and go do your practice. Okay, you should be back from your practice. We are going to go through it together to see if you got them correct. So for the first one, x minus 2 equals 0. Well, let's start with negative 2. Put negative 2 in place of x. Negative 2 minus 2 equals 0. What's negative 2 minus 2? Well, that's the same as negative 2 plus negative 2, which is negative 4. Does negative 4 equal 0? No. So negative 2 does not satisfy my equation. All right, how about negative 5? Negative 5 minus 2 equals 0. Well, minus 2 is the same as plus a negative. Negative 5 plus negative 2. Negative 7 equals 0. Nope. So neither negative 5 nor negative 2 are a root of the equation. Neither one satisfies it. Okay? How about B? I'm going to start with x. Or excuse me, I'm going to start with negative 2 for x. So I have negative 2 squared plus 7 times negative 2 equals negative 10. Negative 2 squared, positive 4 plus 7 times negative 2, negative 14 equals negative 10. 4 plus a negative 14 is a negative 10. Negative 10 equals negative 10? Yep. So negative 2 is a root of the equation. All right, now let's check out negative 5. So I have, I'm running out of room, I'm sorry guys. Negative 5 squared plus 7 times negative 5 equals negative 10. Okay, sorry, I know it's a little difficult to see. So negative 5 squared, what did you get? Positive 25. 7 times negative 5 is negative 35 equals negative 10. 25, positive 25 plus negative 35. That would be a negative 10. So does negative 5 satisfy the equation? Yes, it does, because you ended up with negative 10. So negative 5 is a root. So here they were both not a root, so you should have written out negative 2 is not a root, or something like that. Negative 5 is not a root. And negative 2 is, and negative 5 is on this side. Okay? So something like that is how you should have it written out. Let me know if you have any questions, guys. Love you so much. Bye.